containers in a spreadsheet. That's how you do it, right? This is the sysadmin database of choice, was a Google Doc, and I put what server it was on, what port was open on it, who to contact, and what the app was. And so I was like, hey, if it's down, this is what we do. But when I went on vacation, I gave that spreadsheet to my coworker. I'm saying, hey, just watch this, okay? And if someone calls you, match it up here. That's how it works. We're probably used to that. And then I was noticing that basically every week, one of my container hosts running old versions of RHEL kernel would kernel panic about once a week, so I'd have to go in and restart the box or restart Docker, reload the containers, and I was like, this is boring, and I don't want to do this anymore. I wish there was some automated way to do that. This Kubernetes thing came out, and I was kind of terrified, because even early on, it had this like complexity sort of notion behind it. I'm like, I don't think I want to do that. This complexity is going to be too much. I don't understand all these components. And I definitely don't want to do it if my kernel's panicking every week. And so I found this new operating system called CoreOS with a fancy, shiny, like 4.0 kernel. And we're like, we're going to run it on CoreOS. I was like, okay, how do I automate this setup of CoreOS boxes? And they have cloud-init. And has anyone been running Kubernetes long enough to know the Hypercube? Hypercube was, it was like they took all the components of Kubernetes, the controller manager, the scheduler, the API server, and they put it in a single binary. This huge fat binary that you could just download one thing, and the second argument would be like, hey, Hypercube API server, Hypercube controller manager. And so I would literally, in systemd, curl to bash down the Hypercube, and I would run it in various ways. And that's how I bootstrapped my cluster. And, of course, I was like, it'll take me a couple sprints to figure this out. And I figured out a new operating system and enough to make Kubernetes run. And I had an API server up. And I was just like, okay, well, let me just try it out. I'm going to run a container, nginx. And the command comes back, and it's just empty. And I'm like, well, that didn't work. I'm like, obviously, I'm missing something. This thing is way too complex. I'm never going to figure it out. And I'm like, okay, well, let me go list the containers and see what happened. And sure enough, they were running. And I'm like, well, they're not actually running. There's no way it's running that fast. Let me port forward to it, and it's there. Like, nginx is running. I'm like, okay, let me try scaling it up to 10, because that must have been cached. There must have been something else. Something is wrong here. Kubernetes is too complex. And scale up to 10, and it just works. I was like, I don't know what's going on. But I show my coworker. I'm like, hey, I think I got this Kubernetes thing working. I think we can move off those Docker hosts that I have, and we can start having the web team deploy to this. And what he told me was, that's cool. We can't change everyone's workflow to do that one thing. We can't abandon the 15,000 lines of Perl that we have to provision a box to allow someone to do it this new way. So what you have to do is you have to integrate what you just did into our standard tooling. So it took me 3 months to do that. What I thought was going to be complex with Kubernetes actually was much more simple than backporting everything into our existing frameworks and tools and workflows to make sure that no one had to change anything, and this would just work. But eventually, we got to the point where that was out. Web team could deploy applications automatically in a load balancer, and these hosts were there. And that was my first, 4 months later, my first Kubernetes cluster. And anyone that tells you that cloud native is all about treating your servers like cattle, right? Like that's the thing. Is that if you're a vegetarian, you treat them like crops. Okay, it's like not pets, we want cattle. Not house plants, we want crops. And like that's the cloud native way. And I'm here to tell you that I literally wrote the book about cloud native infrastructure. I have written the definition for the CNCF of what cloud native is, and I'm telling you that that is not true. You do not have to treat your servers as cattle or disposable to get the benefits of cloud native. The benefits come from a lot of different things, but mostly from changing behavior. And that is the thing you actually want to drive. And when we take Kubernetes and shove it into the old way of doing on-prem, that doesn't give you benefits. One of the main reasons that I see a lot of people moving to the cloud, and I worked at Amazon and EKS for quite a while, is because they want to change the behavior and the process of all of their people. And they say, hey, what if all we had was APIs? What if that was it? What if you cannot SSH? Well, you can still SSH. But what if, like to stand up an infrastructure, you have to call APIs? What if everything was API-based? And that's how we're going to change the behavior. And so my first on-prem Kubernetes cluster was absolutely pets, because I ordered the machines, and I helped unbox them and rack and stack them, and they were pets. They had identities on the network that I cared about and I was responsible for. And these were the 6 machines in my first Kubernetes cluster. And they were pets on multiple levels, because if you know any of these characters, some of them are actually pets. And so that was okay, because I cared about the identity of the machine that I was responsible for. The operating system and the workloads were disposable to me. But someone else cared about the identity of the workloads, right? Like that was their pet. The DNS entry to get to their service is not disposable, right? Because there's DNS cache, and you can't just delete that and move it to a new load balancer, because people were going to fail. So there is all of these layers of the stack. Someone cares about them. Someone is responsible for them. And I'm just saying it's okay. If you're running on-prem Kubernetes and someone's like, you have to make it disposable, I'm saying they're making you do too much work. Figure out what layer you care about, and that's okay to make that your pet or the thing that is you're responsible for and maybe can't go away. Fast forward a few years, I still like on-prem Kubernetes. I like Metal. I like doing this stuff. I have worked building it as an engineer, and I've also worked as a provider of these services to other people. When we were building EKS Anywhere at Amazon, I remember that doesn't work, I built a home lab cluster out of an old Mac G4 Cube. Because I needed a lab, and I was like, hey, I want something that looks cool. I want something that actually is neat, and it was my pet, and it still exists. And to my knowledge, it is the most expensive Rickroll that exists, because my node names are never going to give you up. Because I just like to troll people sometimes. But that's okay. Like this talk is to show you that range of all these things that you can do. I am not going to go in depth on a lot of the tools, because I have very specific things that I have used in production, I have built, I know very specific things, I know about a lot of other things, and I would love to talk to other people that have opinions about some of this stuff too, because that's how we learn things. But first, I do want to talk about why are you running on-prem? Because that is an important question, and that is just something that sometimes it's just inertia, and maybe that's fine. And there's lots of reasons. You can have all of your own reasons. And this is usually the one that is the most important, because you do not make the business decisions about where infrastructure runs. And you were told this is where we're running. And that's fine. That is a valid reason that people run on-prem. It's also maybe because you like it a little more. Like maybe you don't like EKS or something else, and you're just like, hey, actually I want to do this. And that is a valid option, even if it's for your resume. Sometimes this is resume-driven development, but remember, you have a business contract with your employer that pays for your time. So don't go too far down that rabbit hole. There are plenty of other reasons, like needing to understand the components. Maybe you need to tweak certain things and you like bare metal. Maybe you don't like calling your service provider and getting API limits raised every week. Maybe you just like to deal with the physics of it and have that be the problem, right? These are, again, completely valid reasons. Maybe, just maybe, you're just like, I need more tickets. I'm going to gin up some reasons that I need to do this. And maybe you just want to understand the broader scope of the impact of something like this that is like the core infrastructure in your environments. And you're like, hey, I actually want to go talk to the network team a little bit more. So this is my gateway to go talk to them. One that I don't think is always a valid reason, but maybe you're not vegetarian and you don't do CrossFits and you need some other identity. Like you need this component that's like, this is who I am now, and I'm going to tell everyone about this thing. And try not to do that one, but I see it pretty often. Yeah. It can be cheaper, and I hear a lot of complaints right now. People are saying that you're running Kubernetes and you're only using 40% of your CPU, right? If you have a sunk, like if it's a CapEx spend, and the only way you can make that cheaper is to use it more, right? You already spent the money, so the thing you can do is to use more of it. But people are like, oh, Kubernetes is only using 40% of the CPU. I'm like, have you ever bought a server from the last 20 years and had someone run one app on it? Like, that's not using even close to that. Like, we can utilize things more. And sometimes we do that through VMs, and we say, oh, we can pack the VMs tighter with containers, and we keep getting these smaller units of things that we ship. And at some point, they're like, hey, how much is enough? How much is enough utilization? How much is this might be cheaper? And running it on-prem in the long term absolutely can be a cheaper way to go. And so, like I said, this is for a lot of different environments. If you are in a data center, and you are responsible for the data center itself and the infrastructure, you will have things that exist in that environment. This is not we are going to replace everything with Kubernetes. If you are trying to replace everything in your data center with Kubernetes, we should talk, because that is probably not what you think is the actual outcome of it. Like, that eventual goal is not going to happen. There are other reasons that people built the data center, and you're not going to shift everything into it. So you have to work with things that exist. All of those other workloads need to know how to get to the work, this stuff happens, right? We just need load balancers. We need ways to discover these things. And if you say, well, if you just move your stuff into Kubernetes, that is definitely the way to start a political battle at any company. Trust me, I know. Those company politics are one of those things that come up, and my first Kubernetes cluster basically failed for these reasons, because I was very naive about what Kubernetes should be to people and how it should be run, and I did not have any of the, I didn't know the reasons that we ran anything else. It's like, why can't it just be Kubernetes? And basically got shut down. If you are in an edge environment, you will have different constraints, and by edge, we want to get on the same definition here. I define this as something with limited capacity. You run in an environment that isn't, data centers also have limited capacity, but that limit is usually like how much power you can get from the power company, or maybe how much cooling you can do. Edge is limited in other reasons, like maybe your network goes down twice a day, or is on like a 4G connection and isn't fast or has high latencies. This is what I'm meaning by edge environments. Maybe you don't own that closet and someone has hardware access to your boxes. Something you may want to consider if you're running this on an edge, and things like cooling and what kind of boxes you get, those are all important too. If you're running this, anyone have a home lab that they run Kubernetes on? Because that's what we thought. Okay, cool, awesome. Other considerations here for if you're running this at home, you probably have a family. They like to see you, I guarantee you. Whether they complain about your bad jokes or not, they probably want to see you at some point. Just beware. If you have pets, not the server kinds, but the ones that might chew on cables or clog your fans with hair, those are problems that you need to consider. How much electricity you actually want to consume, because if you don't have solar or power is expensive, this is a problem. That Supermicro on eBay probably looks great. If you've ever put one in your house or in your living room, you have other things you should just talk to someone about this first before it shows up at the door. These are valid considerations. If your cluster upgrade stops your kids' Fortnite or YouTube, again, you are going to make enemies in your house, and don't do that. But the one that I always come back to is my kids don't know what a pager is, and when I started talking to them about the on-call rotation for this, they were like, "Get out! Like we are not going down this road, and you need to make sure everyone's on the same page of how much responsibility this is going to be." All of those environments have varying ways you have what you're running Kubernetes on, what the OS is actually provisioned to. And I'm breaking this up into a few options of bare metal. But hardware, you just literally, the kernel is the closest to the hardware as it can be, right? We're not virtualizing it. This is just hardware. And if you are responsible for the hardware piece, you also are probably responsible for these things. And in this case, if you are responsible for those things, I'm also saying that your servers are probably pets. This is something that you care about the identity on the network. If you know a MAC address of any of your machines, you probably care. This is just an easy way to determine if you care or not. If you're virtualizing it, then you say someone else cares about that MAC address, and I care about the virtual MAC address, and then you kind of care about these things. And that is maybe better for you. If you have a VMware team, tell them good luck on the migrations. If you don't have a VMware team, then you might also be responsible for this piece. And then again at home, like just make sure you know. Hopefully this battery doesn't die. I don't see any batteries in here, but we'll get something. I love using old enterprise hardware. Like, I think that the micro desktops and even old laptops make great Kubernetes nodes. Just FYI, I've been telling people about that for a long time, and even though I have some Raspberry Pis, almost none of them are part of any of my Kubernetes clusters. So now let's jump into, hey, you've decided that you're going to do this. This is something that you're like, actually, no, I'm all in. Like, this sounds great still. Like, I still want to go with it. There are some options for provisioning, which is specifically like the operating system provisioning usually. Some of these will tie into like, hey, we also do the top level bits of, we'll put things on the OS. But in many cases, these are like, hey, we're just going to get the OS on a box. Oh, thanks. Wait, oh, this is actually like, servers, whether that's bare metal, VMs, whatever, you probably need to install a kernel at some level, and these are some options. Again, I'm not going into all of these in depth because all of these are classes on their own and complete talks. I will say that these are all usually tightly coupled with the operating system they are deploying. So don't give yourself more work. If you are a predominantly RHEL shop, do not use Juju. As much as you might like Juju, and yes, you can do it, and you can cross-provision a lot of these things, but the templates and the defaults are going to be much better if you say, hey, I like this OS, so I'm going to go with that operating system and that vendor stack, because that will save you a lot of time. And provisioning CoreOS, or now Flatcar systems with something that wasn't Matchbox was much more difficult. And then at the bottom here, there are some generic options which like aren't tied to an operating system. Again, those are usually going to be a little more work up front. You're going to have to learn a little more things. You're going to have a lot more flexibility, which also equals more work. Okay, so just be aware that whatever you're picking here for your environments, find the one that's going to be easiest for you, usually. Or the one that already exists. I got to stop clicking on it there. There are lots and lots of products that will install Kubernetes in your environments. This is some of them. This is not all of them. This is just the few that I know that have been around for a while. We'll talk about a couple of them a little more. Oh, by the way, I'm completely biased in this talk. I just want to say, like, this is not a completely neutral talk. I have done a lot of these different things. I have used KubeSpray. I have set up OpenShift. I help build EKS Anywhere. I now work at Talos on Omni. So like, this is absolutely a biased talk. I am sorry. Again, I love to hear your opinions on things, but just FYI, everyone has some biases. If you are looking at any of these things, you probably know at least the basics of what some of them do. But again, I'm not going to go into all of them. I will save you a little bit of time here and just say that if you are not using one of these stacks on the bottom, if you're not already an AWS or GKE customer, you probably don't want to use their products to like provision on-prem. Just FYI, and I help build one of them. If you have never read any news about Broadcom, you may not want to use Tanzu. Just FYI, just if you are looking at Tanzu, I actually think it was a great product when it was coming out. I thought it was a lot. I have friends that work there. There was a lot of cool things they were doing, but in 2024, and you are getting started, go read some news first. Just save yourself some trouble. And for Anthos, it's like whatever the PM wants to rename it next week. It's GKE Enterprise now, I think, but there's another name for it. So yeah. But again, we'll talk a little bit about them. Nutanix, if you're not already using Nutanix to manage some of your stuff, again, it's probably not, like, you don't want to jump into that ecosystem to say, I just want some Kubernetes mixed in with what the other stuff I have. So the other ones might be a little more of a, hey, I just need a little bit less of an ecosystem, and I just want the Kubernetes pieces. And also for like some of these, like you have to be enterprise level customers of them to even get like sign up for support. So like Rancher and Omni and OpenShift, like you can just go like say, hey, like I don't actually have a RHEL contract, but I would like OpenShift support. That's okay. You can minimize the amount of support you're going to get from them as well is a good option. Almost all of those break down into one of these technologies. kubeadm is, if in order to use kubeadm, is a command line tool that will like start a cluster for you. It is embedded in a lot of other tools. It is, if anyone remembers the kubeup script, kubeup.sh was the original bash script that was like 3,000 lines, and it would like stand up a cluster for you in a cloud environment. And we were running this bash, literally curl to bash this thing, and like, hey, I got a cluster, this is amazing. And someone's like, actually, let's make that a little more generic and a little smaller. And kubeadm was kind of the outcome of that. So it was like, hey, we can take any operating system, we can bootstrap your certs, your database, your API server, all that stuff. It has these stages. kubeadm is kind of the way that a lot of people start. If like it's the manual way, it's that. Cloud-init and ignition is obviously like you're starting up a system that's like, I need some configuration. Tell me how to configure. A lot of people just shove kubeadm in there. That's like, it's kind of one and the same at that point when you say, I want to configure this thing. If you're really good about it, or some of these products will do this well, they'll tend to bundle that up into like a Packer image. So they say, okay, now we take that VM, we kubeadm it, and then we roll it in Packer, and then we can deploy the Packer image. And that's how you're gonna get a fully bootstrapped OS in some environments, and that's OS and Kubernetes. So these are just stages of kind of the same thing so far. API-based deployments are kind of, they're kind of missing in a lot of the scope of these things of like, I just want, like, this is what a cloud provider would give you if you're running somewhere else. Like, EKS, give me a cluster. I'm not going to do any of these other things. And that's kind of the interface you're going to get. And that's what Cluster API was supposed to be, is kind of like. Cluster API is kind of a unique beast. Because I feel like Kubernetes, we have forgotten how to make an API that was not a CRD. And we have forgotten how to make any API that we can just call that didn't later require 18 controllers and etcd to store the data. And APIs are kind of missing in all of this. And I can tell you right now that all of the cloud providers that give you a maybe good experience, hopefully reasonable experience if you're going in a cloud environment, do not use Cluster API. Because an API that's well-defined to their service is a much better thing than trying to cobble together Cluster API to do everything. And for most of those providers on the last slide, Cluster API is actually just kubeadm via SSH. It's literally, KubeSpray does the same thing, but where the SSH comes from is different. So with KubeSpray, you're going to do it from your laptop, and with Cluster API, almost all of those providers are, we are going to do this on, if it's bare metal, they will say, you give us the IP address and an SSH cert, and we will kubeadm SSH into that box, and we will suck some data out of it. So just so we like fully understand here, because again, EKS Anywhere was built on Cluster API. It seemed like a good idea at the time. This is what you have to do. You have your laptop, and you say, I want a Kubernetes cluster. And the very first step of anything Cluster API related is to run a Kubernetes cluster. And this is a bootstrapping problem, and some people think it as a good thing, and those people are probably language developers that want to compile, you know, Rust with Rust. And they're like, oh, it's really cool once Rust can compile itself. And it's like, it's really cool once Kubernetes can compile itself. And I'm like, no, it's not always the case. And so you have to run Kubernetes that calls some APIs maybe if you're VMware, but most likely a lot of these are, we're going to SSH to a box and run kubeadm. We're going to suck some data off of it. And then, and we're going to put this back in our little Kubernetes, and then we're going to move it over there. And we're going to run all these controllers, and we're going to run all the CRDs into that cluster we just made so it manages itself. I thought this was a good idea at first. No shade to the cluster API folks. They have done some great work. I think it's really cool. I do not want to be running it, and I don't want to be responsible for it, because if you lose access to those things, cluster or controllers are kind of hard to debug sometimes. If you need to upgrade this cluster, you now need to run another Kubernetes cluster, suck the CRDs out of it, run those controllers locally again, go through and upgrade the cluster, and then put it all back. There you go. There's one. And then throw it back. Your laptop is now like production critical, and we have learned lessons not to do that in the past, and in many cases we are doing this again. And so the brightest idea we have for like, well, don't make your laptop part of production, is we say, okay, well, what if we made another Kubernetes cluster? And what if we put the Kubernetes cluster over there, and it was responsible for the other Kubernetes cluster? And then that Kubernetes cluster makes all of the Kubernetes clusters. Cluster API is not for people that have even dozens of clusters. This is for providers that they're like, hey, I want the flexibility to deploy a cluster everywhere. Because they say, hey, I can take out some of the abstractions of what Kubernetes is, and I can put a bunch of specific details in what that Kubernetes cluster is. And you say, hey, if I want to deploy this to 5 different service providers, maybe Cluster API can condense some of that. But in reality, how are you going to upgrade that cluster there in the middle? Like any other upgrade you've ever done to any core service in your life, your DNS, your DHCP, do you want that in a Kubernetes cluster that you have to upgrade likely 3 times a year? Like the last time I upgraded core services was not 3 times a year. So let's talk about the other options briefly. Again, I am not an expert in all of these things, and I have biases. Kubespray is great because it's a neutral product. It is Ansible based, if you've ever used Ansible, which is SSH and kubeadm. And it just says, hey, I run this SSH from my box. Again, you're putting your box in this production workflow, but maybe it's also Jenkins. Who knows? The cool thing is, because it's just kubeadm, there is no operating system like this. It works better with this one. It's like if you get SSH, it's probably going to work. And this is how a lot of people start, and this is fine. You get an OS on something, Kubespray to it, I have a Kubernetes cluster. That was cool. This is not cool when you're like, that cluster is now 50 nodes or 100 nodes, and you're like, actually SSH is really slow. And it's fine when I'm using it as a person because actually I'm slower than the computer, but when you're trying to automate it and that's running forever and you get all this YAML output, and I'm just like, I don't actually want to look at Ansible playbook runs anymore, please just make someone else do that. If you're getting started and you have small-ish requirements, Kubespray is probably the right option for you. If you have edge locations again with like network connectivity, like SSH isn't great at like, oh, network dropped. Like let's start over. Ansible can do some of that stuff, but again, you're dealing with state on multiple levels of how you SSH'd in, where kubeadm was with it, where Ansible thought the playbook was. There are lots of things to consider here while you're trying to do something like that. How many people are using Rancher? That is one of the most common things that I see in a lot of places, because Rancher has been around for a long time and has a lot of integrations and a lot of features. And it's K3S based, at least I don't know, I used Rancher a long, long time ago, and then I started using RK2 as like testing it and seeing how it worked. I don't know anything that happened in the middle. But it does have a lot of features. A lot of the features with RK2 is, again, it's cluster API based. So it's like, hey, you can deploy Rancher clusters to anywhere. And in this case, that's what the tool's trying to do. And it's saying, hey, I can abstract away some of that stuff. You give me the YAML, and we're going to put this anywhere, right? Because everyone likes writing YAML. Some of the like on-prem provisioning stuff was a little bit lacking last time I tried to deploy this to bare metal. Again, it's like you can do the kubeadm SSH thing. They also have Elemental OS, which is OpenSUSE based, which you kind of build ISOs and then you PXE boot those. I don't have in-depth knowledge on how RKE2 is working. But if you're in that boat and you need a lot of integrations and you want proxy support for like who controls things and RBAC, you should absolutely look at Rancher. K3s based, someone else can tell me this, but like it's a great tool. It is low requirements for a Kubernetes cluster. You don't actually need 5 nodes to run the actual backend, which is usually a problem. And that's awesome because that will probably scale more than most people need. But if you do want high availability and you do need 5 nodes, the story there to get upstream Kubernetes, I don't actually know that piece. I don't know how to make K3s stream across nodes. I know they have backup things for SQLite. That's a question that I don't even have. OpenShift in OKD, as Rancher had lots of features, OpenShift had lots of opinions. And if you are deploying OpenShift, you're going to get everything. You're going to get the CI/CD, you're going to get image streams, you're going to get build packs, you're going to get custom CLI, and Red Hat will tell you all day, every day that it's just Kubernetes. And if you are using OpenShift for just Kubernetes, you don't need OpenShifts, and you are paying way too much money and probably doing too much work. If you're in the RHEL stack, the Red Hat stack of things, I guess the IBM stack, I don't know. It's CoreOS based now. It's a lot of things that get mixed in there. I don't know. If you're in that stack, you probably know what it's like to run Red Hat enterprise software and how those upgrades work. And every time that I would upgrade our Rev servers, which I think rebranded now, or our directory servers or Foreman, those were big events, and I don't like having pieces of software that have big events to do. But if you are in that space, this is probably the right option because you already have a support contract. And if you have 0 opinions, this is the one to look at. I will talk about EKS Anywhere just because I'm very familiar with it. And to my knowledge, it's the only cluster API-based provisioner that is not SSH with kubeadm. Because with EKS Anywhere, they decided that we wanted to own the full provisioning of a server with bare metal. There is also other providers that are CAPI based, but it runs Tinkerbell. And Tinkerbell is a generic OS provisioner that came out of Equinix metal, and so they run Tinkerbell. And it's a very interesting tool, and it is a very complex tool. And when you put CAPI on top of it and you run it in Kubernetes, again, I do not think that every tool that you're running in your data center should be running in Kubernetes, especially the core services that are required to spin up Kubernetes. And EKS Anywhere has the same kind of model of admin clusters that create other clusters. Surprisingly, EKS Anywhere doesn't run any of the Amazon Linux distros. Politics. So we originally shipped it with Ubuntu, and then we had to shift people over to build their own Ubuntu, and it does support RHEL now, I think, but it's a long process to get to a cluster, and I was training people on this for over a year, and when I've come to discover when the first step of I want to deploy a Kubernetes cluster and I say give me a MAC address, that's probably the wrong question. It's like you gotta make a CSV file with MAC addresses is not how you necessarily should. That's not the best practice. It is an old practice. It exists for a while, but when you're doing this inside of Kubernetes, just maybe not. I do now work at a company called Side Arrow Labs. We make a tool called Omni. The thing I knew about Talos Linux 7 years ago when I was still building my on-prem Kubernetes. And the interesting thing about it was the fact that the operating system only has an API. There is no SSH. There is no, the thing that we wanted people to do to move while we moved to a cloud, we say everything's API based. So that's the thing we want, and we want people to change behavior. It's hard to do when you still give them all the other stuff. And Talos Linux only has an API, and it only works with Kubernetes. So this isn't a generic purpose Kubernetes. This isn't a thing that you're like, oh, we could actually just use this everywhere. It's like, no, you only use this with Kubernetes. There are, I literally, when I started the company, I went through and I counted. There are 12 binaries on the entire operating system. And that's interesting to me, because I could sit down and tell you all of them. And I can tell you half of them are for formatting disks. That is because it works on bare metal and because it works in environments. Like, hey, actually, we just need to make a file system, and so like that's how LVM and all these other things work. And so we pull those things in, but like 3 of them are just like, well, here's the API, and you can deploy this, and that's like, oh, that's what I want from AWS. Is I just want the API to do the thing, and Omni like controls all that. The one thing that it's available for home lab use or test environments, but it gives you an API that's not cluster API based. That is just like a standard API. Like I can just call an API and like deploy an operating system and Kubernetes without baking things and without scripting things and without doing all that other stuff, which I really, really enjoyed. The first time I did, I'm literally building Kubernetes or EKS Anywhere, and I try out this thing, and I'm like, wait a minute, this should be harder. It's like all the complications, we're building it into ourselves, is not necessarily the thing that you want for an on-prem environment. In Kubernetes, again, it is complicated, and I am a testament that it can be as complicated as you want it to be and as integrated as you want it to all those other things, but the complications are probably from all the other things you have, and because you're trying to fit that new thing, that the behavior you want to change, into that 15,000-line Perl script. And once you say, like, I need Kubernetes to work with that, then you're probably not going to get some of those benefits. And that's the thing that I think is one of those critical, important things that a lot of people just miss. And they're like, we just want Kubernetes in the way we've always been doing servers. And so that's my opinion on it. I could give a demo. I don't need to give a demo. I don't always like giving demos, and I actually don't even think I have it set up right now. And it'd be hard to do with one hand. So I can answer questions if anyone has questions about on-prem Kubernetes. And again, if you want to talk about some of those other options that I talked about and I don't know about, if you have another, like, I think this one's great, please tell me about it. And since my other mic is dead and I have no proctor in the room, I'm going to be running the mic for you.
With Cluster API, you mentioned you can provide, so I looked at Cluster API in the past. It seemed like, to the points I think you were making earlier, you have to feed in a fair amount of configuration to get working, where it kind of felt easier using Terraform. And it sounds like there's another option where you could use Cluster API if you just already have nodes set up, and it just uses kubeadm over SSH. Is that correct?
Yeah, most of those providers will SSH your node. You give it IP addresses and SSH key, and it says, okay, I'm going to go SSH to them from a Kubernetes pod. I'm going to spin that up. I'm going to SSH in. I'm going to run kubeadm steps, and then we're going to suck some data back and know the state. And some of them, like Rancher, will install an agent, and it will report back and say, hey, I'm going to keep this state going. Some of them will do it with a workload. It says, I'm going to deploy a daemon set, and we're going to suck that information back. They do it all different ways, but like the initial setup is like, I need SSH to that box. And if you are doing Kubernetes and you say, like, I need a full general purpose Linux, then like you might be doing too much work. And systemd, I think, is a fantastic init system, but it also makes a lot of work. Like it just adds a lot of bloat to a system that's like, actually, I need to run the kubelet in containerd. Maybe I don't need everything. And that's one of the really cool things about some of the minimal operating systems. That's like, let's just strip that down a little bit.
So I've seen different things pertaining to Rancher OS and OKD. And so what exactly would be the difference between them? Because I know they both have their monitoring something or other, and they both have their CI/CD something or other. So why would one choose one or the other? What would be the difference?
And I would say if you are on the RHEL stack, choose OpenShift. If you are not, you'll probably want to choose Rancher. Like that's like the main difference. And I mean, they're both like, Rancher is going to be SUSE based, and you're going to be a SUSE customer. The hardest thing most of the time with on-prem environments for me was I had to go talk to a lawyer to like buy support somewhere. And like that's the thing that took the longest a lot of times. It's like I need someone like to be able to support this because it's a production workload, whatever reason. It cannot just be my team that supports this. And whoever you have relationships with usually is the one that I say go with that one to start. And I know a lot of people that OpenShift was a great starting point as people started containerizing things, and they have all the build packs and they have all the stuff that's like, hey, we can move this to OpenShift really quick. And then they find out they don't like some of the opinions. And they say, oh, actually, like I want it to be different. I want to use Jenkins for whatever reason. I want to use something else. And once you have your own opinions, OpenShift might confine you a little too much. I still feel like OpenShift is opinions and Rancher is features. And Rancher has a few more that are flexible that you're like, hey, I can use your defaults, but also I have a little more flexibility in how I tie that in. Oh.
So another one, I guess on TalOS in particular, we're getting requirements from some of our customers for FEM. And I know nothing about FEM, but is TalOS or some of these newer methods that use like flat car Linux compatible with those methods?
I will generically answer that in that most of those, we have a requirement for some security thing, we need validation on this thing. The more you can push away of like, it's not possible, it takes longer for the rest of whatever spec to catch up with, like, it's not possible. One of the reasons we had a lot of people in AWS use Fargate was like, hey, you just can't do that anymore. You don't have any access to the host, so that problem goes away. And we had a lot of people that are like, hey, I love problems going away. And that's one of the things with something like Talos that has no SSH. That's like, what do you need to do? It's like, oh, we need to make sure SSH is secure. Literally, Talos is not in the AWS Marketplace because AWS Marketplace requires us to verify that our SSH keys are like secure. I'm like, we can't. Like, there's nothing. Like, I can't do anything about it. Like, there's nothing we can do. And so, like, there is this moment of like, hey, this just doesn't, it's not a thing anymore because we've thought about this differently. And it does take time for that stuff to catch up. And so if you have a hard requirement on an industry standard or something that's like you need this certification or you need this other thing, that stuff just takes time for most of the industry to catch up on any sort of certification. So I don't know the specifics on that requirements, but I do know that like almost all of them, it's just like, it just takes a while for them to understand like, oh, we have to do things different. Every like security vendor, and things in the past that were like, hey, we need to validate this thing. I remember one of our requests early on was like, we had a requirement on Active Directory for all of our servers, even the Linux boxes. And they're like, hey, we need you to run all of your containers and join them to Active Directory. Because that was the spec that said, hey, this is how we validate things, and this is how we have controls over things. And I was like, no, you will not, like we will have other problems in this space, even if you're adding these pods into your generic pools of IP addresses, like these are ephemeral, and we don't want them to come up, get IP, go down, and joining, like all that stuff goes out the window. So like there's just a lot that catches up in any of these environments, and as you minimize your responsibility, you have to just have that conversation of like, hey, what are we actually doing here? And in most cases, all the daemons that were like, hey, we need kernel modules. It's like, how are those kernel modules getting there? Like, well, we do it in the bootstrap process. It goes in Packer, or we SSH in. It's like, okay, well, maybe we don't. And eBPF and some things are catching up. There's still a lot that is not there. Most of the tools that don't work with Talos right now are because they exec into the host and they expect binaries to be there. And they're like, hey, where's my bash? I was like, sorry, your tool doesn't work because you literally shell into the host and use bash. I was like, that is just SSH. Like, you just did it the same way.
Thank you. Coming from a non-Kubernetes guy, just learning, I think you kind of touched on maybe cyber security frameworks that these environments need to match up with. Would pretty much a lot of this be figured out in development, kind of seeing what works, what doesn't, and then you have some end goals of maybe aligning what the industry needs or the company needs for frameworks. This would be settled in development before it reach production?
I mean, for sure, if you have a hard requirement on some security specs or some benchmarking tools, you do need to obviously figure those things out ahead of time. A lot of the conversations I've had at enterprises of like, we have a security spec is like, okay, what are you doing? And like, well, we had a hack on this thing a long time ago, and now we have a requirement to check the box because that thing happened. Even if it wasn't to us, it was to someone else, right? And I worked at Disney when Sony got hacked, and we went through and like audited everything because we're like, oh, what's going on? Like, oh, actually, they mostly ran Windows, and we didn't run any Windows. And it's like, does that mean the security's not a problem for us? No, absolutely. Like, there were still things that we wanted to make sure, but we had to check some boxes to make sure that that was all right. And in any of these environments, if you're deploying this in production, especially if it's going to be publicly accessible by someone, you do need to make sure that the baseline security is there. But again, like I was saying, like a lot of those problems might just go away because you don't have root on a box. You don't have shell on a box. If someone wants to pop a shell, like they can't. It's just like literally like, oh, it's not there. So yeah, figure those out in development. If you want to kick the tires, especially on something like you'll want to do multiple layers. Like the Kubernetes layer is its own security thing, and I think we have a Kubernetes security talk later today. Those are things you'll want to look at as you're going through this, but figure out who's responsible for which layer, because that's a very important thing, and one person's not responsible for the whole thing because there's too much. So, I'm going to take one more because we have this vendor shout out, and I did forget. I think it's in this room. I'm really sorry. We had 3 cancellations for speakers. So if you're looking at the schedule on the printouts, that was printed last week. Look at the online schedule, because unfortunately we had some people that didn't make it and got sick. And so, yeah, please look at the schedule, but I want to give time for the vendor as well.
So I work for an organization that is running on-prem K8s clusters. We build them manually, mostly through Ansible. I just started about 6 months ago. They're very firmly in the camp of this is cattle, not pets. But I'm the backup administrator. I want to find a way to be able to adequately protect these clusters so that we don't have to try to rebuild them from scratch, something they don't do very often and thus is largely unproven. What's your opinion on that?
The first thing I always ask with backups is what are you trying to prevent? What are you trying like there's data loss, there's crypto jacking, whatever, like there's something that's happening that you're like, I need to back up something for these reasons, and there's a reason behind the backups. And usually that's like hardware failure, we get a new hard drive, we have to restore the hard drive. Workloads that took someone some amount of time, maybe days or weeks to create this thing, now we don't want to have to make them redo that again. And Kubernetes, again, it depends on which identity you care about. And if they're redeploying clusters, if they're redeploying the OS and the workloads, maybe you don't care about the workloads because the state for that is in a database and you care about backing up the database and not the pods themselves. The operating system, if it's ephemeral or if they throw it away or like some of them are read-only operating systems. Like you don't need to back up. Like if you're backing up a read-only operating system, you're probably wasting your time just because that's not meant to be backed up. It's meant to be provisioned on the fly. But if you're doing like disaster recovery and you're saying, hey, actually, we don't know if our NFS is going to be available when you try to redeploy and all this stuff pulls off of NFS. So is production going to be impacted because NFS is down? We need to do a backup or we need to have a disaster recovery scenario to prevent that. Those are the questions I usually ask and say, okay, which layer do you actually care about? Because you can go all the way down to like, I'm backing up firmware on the boxes, right? Like maybe you don't care about the firmware. Like there's some layer in there that you're like, actually, this is the thing that I want to prevent. Find that one. There are Kubernetes workload backup tools that'll say like, hey, we'll suck out your workloads. We'll find any volumes that they're using, if it's stateful. We'll do all that stuff in the Kubernetes layer. There are obviously lots of tools, especially if you're on like a VM host, like I'll back up the disk, the vdisk, or whatever it is to get the host. But you might be just storing too much stuff if you don't care about it. But the thing that I found really interesting was the fact that they're treating it like cattle and they're not redeploying frequently. That is something that maybe they're not treating it like cattle. Maybe they do care about something and they just want to think that they're doing it the right way by saying this is cattle. And that's the thing that I would push back on them is, okay, if this is your cattle, I have a new box, create me a new cluster. And then figure out from that, how many things did you not have backed up? Because they're going to have a GitOps repo or something, a bunch of YAML and a bunch of Ansible, and they're going to say, okay, we can deploy it anywhere, anytime. I'm like, okay, how'd the OS get there? Who was responsible for that? How'd the network connections get there? How'd the load balancer get set up? And if those are the things that are the gaps, maybe the backup strategy is automation on other things and not just that layer. So that's what I would push back on them and say like, hey, if you say you're doing it this way, let's talk. And let's figure out what we're trying to prevent. So again, I'm around all weekend. Thank you very much for coming. And I want to give, again, vendors and sponsors are why you're here. Please stay for 2 minutes because they paid money and they also want to talk to you and you're probably going to learn something.